Good evening. Today we are going to explain the integrated circuit. So this is in the fifth module. So this is nothing but integrated circuit is nothing. IC it is called as a integrated circuit. So it is a low cost electronic circuit consisting of active and passive components. These all are fabricated together in a single silicon chip. The active components are transistors and diodes, and the passive components are resistors and capacitors. So, in the recent past, it has been possible to fabricate many hundreds and thousands of active and passive components in on small silicon chips. Such all the devices are fabricated in a single IC. We can connect more than 4 or 5 gates are connected in a single chip. So the integrated circuits are broadly classified into uh, linear or analog IC or digital ICs. Now, the mainly it is classified into 5 types. They are SSI, small scale integrated circuits. So here we are observing a diagram. On this diagram, you are observing the pins. These are the pin configuration, and both sides we have a pin configuration. Depending upon the pin configuration, we can explain what is the number which by using we have on the top of the chip we have a number is there. By using number, we can identify that is belongs to which gate. Nowadays, where they prepare a very large circuits, ultra circuits. So we'll explain later. First, the small scale integrated circuits. So it consisting of 12 gates per IC and total number of components per chip is less than 100. Means 12 gates are nothing but each if we are taking the 2 input AND gate, it required 3 pins. Okay, so means here these 3 pins first they are used for one gate and next 3 pins are used for another gate. So in this manner, minimum 12 gates are present in a particular IC means 3 into 12 means how many pins? 12 3s are 36 plus 1 is VCC and 1 is ground. So total 38 pins are there. 38 pins are present means that is under the belongs of small scale integrated circuit. So it consisting of 12 gates per IC. Each IC it consisting of 12 gates and less than 100 components are. Now, next one is the medium scale integrated circuit. This medium scale integrated circuit consisting of 12 to 100 gates per IC. Here 12 gates is maximum. The medium scale we have a 12 to 100 gates per IC. Now the total number of components per IC is 100 to 1000 components. Next one is the large scale integrated circuit. These are called LSI. So it having here 100 gates. Above 100 and 2000 gates, that IC is nothing but large scale integrated circuits. Next, very large scale integrated circuit that is called VLSI. So here it contains 1000 to less than 10,000 gates per IC and the total number of components per IC is 10,000 to 1 lakh. That is VLSI. Now they are preparing the ultra large scale integrated circuits. Means more gates are present here. So they are very useful nowadays. Ultra large scale integrated circuits. These are the classification of ICs. Now coming to the gate. Now this is the gate number 7408 is the gate number for which gate. This is the 2 input AND gate number. So here if in all ICs on the top of this black coating on the top they mention the name as this 74LS08 means 7408 that represents the AND gate. LS means depending on company, they will change the middle two letters, or they change or not change. But 7408 IC number, that is belongs to the AND gate only. So this AND gate, it contains 4 independent gates, such each of them performs the logic AND function. So what is the AND function? If the two inputs are low, the output is low. If the two inputs are high, the output is high. Now, if it is any one is high or any one is low, the output is low. Means finally you are getting when the two inputs are high only, this AND gate working. Okay. Now here, this is the pin configuration. This is the 16 pin configuration. Sorry, 14 pin configuration IC this is. Now in this, they represent A1, B1, Y1 is there. So this is the A, B1, Y1 that is belongs to one AND gate. One AND gate, A1, B1 is the two inputs of that AND gate, and Y1 with the output of this AND gate will be connected here, so that we are getting the output. Next we are taking here A2, B2. This is another gate we are taking. The output will be connected here. So this is internally connected. Now we are only going the connected just by using this IC. We can connect the total 4 AND gates are connected by using this IT. We can use any two also, any one depending upon use. But in this IC, 4 AND gates are present. So this is the pin configuration. Definitely we are connecting that pin is nothing but that is belongs to, that is input or output. If you want to connect this one, means input 2 connected here, the next pin is the output of that. No need to connect here. You have to connect here only, so that you are getting the output. Otherwise you will get the output. Means you have to remember the pin configuration. What are the input pins and what are the output pins, you have to remember. And one pin is this side. One side we having the 2 gates here. One side having the 2 gates. And another side we having the 2 gates. Now this symbol is there here. That is the starting of that gate is present that side. Means here in this, in the black chip, we having a one oval symbol is there. And that symbol, this gate is the input of the one gate. So count that pins. By using that, you can connect the which gate is you want, that gate you are going to connect. So that's identification is by using this only, this symbol. By using this symbol, this is the first input, second input, and finally the 2 input output is coming from here. So this is 74LS08. 7408, it performs the logic and operation. Now coming to the next operation. Next gate. Now this is the next gate. Now this is the OR gate. So that number is nothing but IC7432 is the number for OR gate. Now this is, in this IC also we have 14 pins. The 14 pins means that is nothing but 4 gates are present. 4 OR gates are present in this. So here also same the symbol and same pin configuration. And at the symbol we have first, second and output of the first gate, and 4th pin and 5th pin. Here 4th pin and 5th pin, input of OR gate. Here also these two are input terminals, and this 6th is the output terminal. Now 7th is ground. 7th pin is ground. And coming to 8th, 9th, 10th belongs to one gate. And 11, 12, 13 pins, this belongs to another gate. So some this V plus voltage means that is the VCC is there. This is the VCC pin and this is the ground pin. So these are at the, definitely 14th pin is the VCC and 7th pin is the ground pin. Next, this is about OR gate. Now what is the output of the OR gate? If the two inputs are low, only you are getting the output is low, otherwise you are getting the output is high. If any one input is high, you are getting the output is high. And both inputs are high also, you are getting the output is high. So this is about RIC. Now, next one is NOT. This NOT is somewhat different. Why? Because and OR gate having the two input and one output, but here the NOT, they're having only single input, single output. So that's why we have a 14 pins. In the 14 pins, when we are removing the two pins, one for ground and one for VCC, the remaining 12 pins means required only two pins, so that 6 gates are present in this. One is input and another one is output. So the truth table for NOT gate is if the input is high and the output is low. If the input is low, the output is the high. Now the number of NOT IC is nothing but 7404. You have to remember this one. 7404 is belongs to the NOT IC. It is a 14 pin IC. And here the symbol after this is the first gate input. If the input is high, the output is low. If the input is low, the output is high. This is the first gate. Second gate and third gate. This is for ground. Seventh pin is ground belongs to. Next 8, 9 and 10, 11, 12, 13 and 14th pin is nothing but VCC. This is the about the 7404 for NOT gate. Next, coming to the 7400, that is NAND IC. Here they wrote 74LS90. Already I told LS is the name of manufacturing company symbol, indication purpose. Anyone, but the number is constant 7400. That is for AND gate. So NAND gate. So NAND is completely opposite of AND. Not plus AND, we are getting the NAND gate. So in the NAND gate also we have the total. This is also 2 input NAND gate. So 2 input NAND gate, it require 3 pins. So here it is the 14 pin same, and the 7th pin is ground and 14th pin is VCC. Okay. Now this is the input pins. These two are output pins, same symbol. Now this is the number for NAND gate. Now coming to the NOR. This is the NOR gate. That number is nothing but 7402. Now, observing the NAND, here the pins 13, 12 are the input pins, 11 is the output pin, and 10, 9 are the input pin, 8 is the output. But here, different is there. 8, 9 is the input and 10 is the output. And 13, 12 is the input, 13 is the output. So that is the difference for NAND gate diagram and NOR gate. You are observe that one. So remaining all gates are drawing in the same manner, but this pin configuration is different for other than gates. And this is the number same, but input output connection pins are somewhat different than other gates. So this number is 7402 NOR. NOR is nothing but OR plus NOT is a NOR gate. And it is completely opposite to the OR gate. If R is high, OR gate output is high, NOR gate output is low. Why? Because if the input high, the coming from the out gate of the NOT gate, we are getting a low. Low, high. That's why the NOR is the completely opposite to the OR gate. That is about the NOR gate. So you have to remember this pin configuration is different for other configurations. Now,